Well, and the most important factor in determining the best architecture is really just how popular it is, because you know
How do you check popularity? Is this like just Google search ranking? Like, sorry, Google search popularity?
tweets, Medium article likes, that kind of thing. Because you want to be one of the cool kids, you got to ride the trends,
Oh,
ride the hype trains.
like how do you know if you're on the right hype train? Is it how do you know? What
Uh,
does your heart tell you?
well, for architecture specifically, you'll know because you'll have a whole bunch of people asking senior developers if MVVM or some architecture is better than X architecture, or like what is the best architecture.
I think I feel like we're being misled, and the real best architecture is the one in your heart.
Yep. Heart driven architecture. Okay, what's up, everybody? So, yeah, first off, I just want to say thank you to Shalom and FaZe and everyone else. I'm sorry if I forgot your names for setting up Android Worldwide and also giving me the opportunity to talk. I said this to a few people individually, but Android Worldwide really feels like the best parts of the Android community coming together without all the negativity. So it's really a lot of fun to take part in. I'm just going to mess around with my slides so I can hide my toolbar. So let's get started. Todd says there better be a dance routine. I don't think you want to see me dancing. Anyways, so my talk is on the golden principles of software architecture. Having watched Gabor Varadi's talk, I'm going to sort of rebrand it as the introductory talk for his, because basically we're going to cover a lot of the same bases, but I'm going to cover some introductory type stuff like what actually is separation of concerns, what are abstractions, and how to use them. It's not going to be a super code heavy talk, but what I would like to do is I'd like to try and clear up some really common misconceptions. Basically, this talk is based on the things that I get asked all the time when I'm doing my live Q&A. So without further rambling, let's get started. So the goals of my talk are to clear up those common misconceptions, which I hear about all the time and am asked pretty much every Sunday. We're also going to learn how to sort of derive an architecture just by looking at the code in front of you. And that's a lot simpler than it might sound. We're going to learn what abstractions are. In my case, learning what abstractions were in general, almost philosophically, helped me understand exactly how to use them in my code. And then we're also going to talk about the benefits of using fewer third-party libraries in a very general way. So the first principle I want to talk about is separation of concerns. And I consider it to be the most important concept in software architecture, which is kind of why I refer to it as a golden principle here. In a sense, every architecture you've ever learned about is merely applied separation of concerns. We get used to thinking of software architecture mostly as meaning some kind of three-layer architecture, model view controller, model view view model, model view intent, or something like that. And being sort of raised with that three-layer model in mind, we kind of get locked into some interesting bad ideas that I would like to address here. So the first thing, and I get asked this a lot, sometimes it's just someone literally asking, what is the best architecture? Sometimes they'll say MVC versus MVP. Usually lately it's been MVVM versus MVI. And so there's actually a really simple answer to this particular question. The best architecture is actually, it depends on the project requirements. Now, you could get into some very specific code examples, and I think it's useful to do that. But how can we understand why this is the case in a very simple way of thinking about it? We could get together and design an architecture for, say, like a 2-bedroom apartment. And we could really come to something that's we agree is pretty optimal. Would it make sense to then take that architecture and apply it to something like a hospital or a car factory? Obviously, that would not be the case. So really the key here is that the best architecture really must necessarily be dictated by the project requirements, and those change quite frequently. So it's worth asking the question, because we get locked into this sort of 3-layer idea, are 3 layers enough? So what I would like to do is I would like to talk about some separations of code just by looking or considering the kind of things that we normally write. And then we'll follow up by asking that same question. Should we really be representing this or modeling this using something with just 3 layers? Before we get there, I just want to briefly define separation of concerns. Often it's called modularity. That's sort of another word for it. And it's worth spending a moment talking about why separation of concerns is actually useful for you. The way I like to introduce this topic in general, and this is a true story. I was once walking to work, and me being me, I just happened to notice that some sidewalks or footpaths, as my friends in the UK say, were made of like a continuous layer of concrete or asphalt, or as my American friends say, asphalt. True story. And then some sidewalks were created with individual squares. And of course, I asked myself the question, why would you bother making a sidewalk out of individual squares? And if you're ever nerdy and obsessive to that degree like me, then you'll start to arrive at some interesting conclusions. If one square gets broken, it's easier to replace. If there's an issue in one square, another way of saying that is if there's an issue in one square, it doesn't tend to extend and affect the other squares, or it tends to do so a lot less. Some other interesting side effects: you can build the squares individually in isolation of each other. And if you wanted to, you could test the integrity of each square individually. I find this to be just a really useful general analogy for separation of concerns. So what we're going to do now is we're going to look at the kinds of code that I typically see in GUI applications. There's going to be a lot more, but we're just trying to get a sense of what are some more separations we could potentially apply. So we have this thing that I like to call session storage. It's really just like short-term storage that generally won't last longer than a process. A process is a running program, for those who don't know. Maybe it might last a little bit longer. We're talking about UI state, navigation state, authentication state. On Android in particular, this stuff tends to be tightly coupled to the platform. Like your for UI state and stuff like that, you're probably going to need to be using on save instance state, on restore instance state, maybe save state handle for view models, or remember savable for composables. There's, generally speaking, going to be this hook to the user interface, which makes this, it gives this code a unique concern and tight coupling issue. Of course, we have long-term storage. So oftentimes this stuff isn't actually tightly coupled to the platform, but it will very often be tightly coupled to a specific library or API. This presents some difficulties in testing because if you want to sort of mock an API like that, you're sort of pretending like your mock is actually going to be behaving like the actual API. Generally speaking, if you want to test this kind of thing, for me personally, I will try to set up like a test database or a test web server, for example, and test this kind of thing in integration tests. But people have different approaches. Point being, it presents some difficulties with difficult to mock dependencies. We could also be talking about like online, offline caching, but that kind of depends on what you need to use that for. We have, of course, our UI platform and framework code. So we're thinking activities, fragments, JavaFX for desktop, or Swing, Swift UI. And this stuff, again, is really quite tricky to test in general. You've pretty much got two options. Again, you could use frameworks to mock the code, and you're kind of hoping that those frameworks will behave similarly to the actual platform code. This, for me, again, is the kind of thing that I would probably test by actually deploying to a device or an emulator or something like that. We have, of course, just drivers. So we're thinking about like window and screen managers, system services, inter-process communication. Again, like not really the kind of thing that you can mock very easily. So moving into some of the stuff that is easier to test depending on how you set it up is one example of a couple different kinds of logic that I like to talk about is, of course, presentation logic. It's the logic required to draw things on the screen and sort of interact with them. Up on the screen here, all of a sudden we have a whole bunch of code. What's going on here is I've been experimenting a lot with composables and using sort of my own approach to architecture. What I've found to be most useful, both in the view system as
Ryan,
well as, yep.
sorry to interrupt. There's a little white dialogue that's covering a bit of your code. We kind of just haven't commented on it because it wasn't interrupting anything, but all right. Sorry for interrupting.
It's all good. Appreciate that. So, we've got, so I've been experimenting with different kinds of architectures, and the general principle that I'm trying to apply here is when it comes to things that are tightly coupled to the view system or composables, I try to pull the presentation logic out as much as possible into classes which are actually easy to test. And that's my general recommendation there. We have this thing that I like to call control logic, which is something you should be familiar with if you study computers at a really low level. But we do see this kind of thing in application code. So basically, we're talking about handling events and sort of passing data to different classes and functions in the application. Again, this is something I find if you can pull it out into something that's easy to test, i.e. doesn't have a lot of annoying dependencies, then it's something that's just really easy to cover quickly in unit tests, for example. My least favorite to write, but favorite to test is what I like to call computation logic. So for computation logic, we're thinking of stuff that's very mathematical and kind of pure. You give it some kind of input and you test the result. You can see on the screen here, I don't know if that's the right or the left side for you. That's a screenshot of part of the seed colors algorithm. I wrote an application which generated dynamically sized and dynamic difficulty Sudoku puzzles. And the code itself was just a nightmare to write. But because I wrote it all in standard library and it was completely decoupled from everything else, not only was I able to reuse it in the multi-platform version of my application without making any changes, but I was able to actually apply test-driven development, incrementally prove every step as I wrote it, and then get 100% code coverage, which was really cool. We also have this thing that I like to call build logic. We were debating this earlier. Some people would call this dependency injection. I agree that the code on the screen here would be dependency injection with the presentation logic. But what we're talking about, to quote Martin Fowler, is separating configuration from use. The way I like to sort of explain it is things that use things should not also build those things. Hopefully that kind of makes sense for you. But again, an interesting thing here is a lot of people use libraries for this. If we're talking about medium to small sized applications, it's worth noting that this code is, generally speaking, very easy to write yourself. So we're going to revisit that question. Is 3 layers enough with some personal experience? How many of you have done Model View Presenter or Model View View Model? Maybe you were just starting out with it and you ran into one of these situations. Like I started with Model View Presenter, and basically the main issue that I ran into with Model View Presenter is where the hell do I store the UI state? And there were a lot of funny workarounds to dealing with this. You could sort of do it properly and store it in on save instance state, on restore instance state, but then you had to like synchronize your presenter with the life cycle, and it was kind of a major headache. Some people would literally just store the state in the presenter, which I like to call Model View Presenter cache. Not the best idea. And of course, in about, I think 2017 or 2018, the Android team came up with their preferred style of architecture. And there's a lot of, I could go into with the history here, but this was always very funny to me because right off the bat, I saw people basically saying, okay, we've got this new architecture and it solves this problem of UI state. But I guess people were assuming that maybe just because it has different letters and it doesn't say anything about presentation logic, that the presentation logic magically disappears, which was not actually the case. So then we would get the pattern, which I see very, very often today, to this day, which I like to call view model presenter architecture. So my my argument here is not to pick on any particular architecture, and there's ways you could do model view presenter that worked. There's ways you could do model view model that worked. But I think a lot of people run into problems when they're trying to have this 3-layer model or paradigm, and they're trying to stick it on any kind of project requirement or feature requirement. And the reason why I went through a couple different separations is because I want to encourage you to consider, maybe I could pull the presentation logic back out into an easily testable class that's, I don't really like using this word, but stateless, easy to unit test. Or maybe if you're still hooked on doing model view presenter, consider adding in a view model, which actually does what view models were supposed to do, which is to basically maintain state across orientation changes and stuff like that. Personally, that's what I often do. But really what I'm encouraging you to do is to actually look at the code and based on what you see, consider separating things. Now, some people hearing that might be hearing me tell you to separate everything all the time. There was a time in my career when I would do that. If you want more info on that, certainly consider Gabor's talk. I'm not actually telling you to do that. Don't separate things just for the sake of separating. However, if your model view, whatever architecture, starts to look like crap and you find yourself fighting with it, then that's usually a good indicator that you might need to pull something out, particularly if you care about testing. Conversely, to give a quick practical example, I recently made a single primary screen application, a weather application using Jetpack Compose, and it uses the fused location provider API to get the device's location, which I pass to a remote API. 2016, 2017, Ryan would have taken the fused location API provider and pulled it at the far end of my architecture behind 7 layers of abstraction and all this crap. When I made it this week, or not this week, when I made it this last year, I just actually kept it in the activity and everything works fine. So don't separate for the sake of separating, but just, especially with the core application logic, consider separating it for testing purposes. Now we're going to talk about abstractions. I jokingly feel like this is the beginner introduction to Gabor's talk because I'm going to be covering a lot of things he gets into, but just basic level. So abstractions is a very interesting topic. The subtitle here is The Solution to Too Much Information. So before we get into using abstractions in your code bases, again, I always like to try and introduce things with some kind of analogy. Abstractions are amazing because if you really go down the philosophical rabbit hole here, you'll see that pretty much everything you interact with reality is actually an abstraction, including your thoughts and all that stuff. We're not going to go there. One example of an abstraction as a noun would be like a picture. I've got a picture of a venomous snake. I used to say poisonous snake, but apparently there's an important difference there. Let's say you were traveling to some country and it had some kind of venomous snake, and you wanted to learn about it. One way you could do that is you could charge into the wilds and try and locate one for yourself and do it that way. You could also just jump on Wikipedia. You could get a picture of the snake, which is an abstraction. You could get verbal descriptions of the snake or its habitat and so forth. Basically, the point of the abstraction here is to give you all the details that you need without actually having to get bit by a venomous snake. So we can also think of abstraction as sort of a process, which is important. And in this case, we're reducing details in order to increase efficiency or flexibility. And we're going to look at a couple of different examples in code or ways we can achieve that in our code in a very high level way. We're not going to go into super complex examples. Before we get to that, I want to explain what interfaces are using an analogy of interfaces in mechanical engineering. I'm not a mechanical engineer, but I did grow up on a farm. In the middle of the slide here, we have what's known as a power takeoff. It's a PTO. What it does is it rotates, and that rotation will drive the implement, the tool. They're called implements, incidentally. And so basically, how this works is as long as any kind of tractor knows about or sort of understands or can communicate using the interface, the PTO, any kind of tool can then communicate with the tractor and vice versa. So the key point here is that the different objects, by knowing the interface, we get this flexibility where they don't need to know specifically like what model of tractor it is or even what tool is using. So to me, that's kind of the best way to introduce interfaces rather than just going into super like if you read the Oracle definition of an interface and you're a junior developer, prepare to cry. I pretty much did. Now we can look at it as sort of a language feature. And most of you should be familiar here, but how this is typically described. So on the, hopefully the left side of the screen, we have this thing called iTask view. If you're wondering what the top level interface is for, it's really just a namespace. Otherwise, it's just a totally pointless layer. It's just a namespace here. But basically what interfaces allow you to do is they allow you to have the same behavior with different implementations. Let me explain that again in terms that will make sense to people who don't already know what I'm talking about. When people say behavior, what they really very specifically mean is function declarations in absence of the function body or method body in Java. When we talk about implementation, we're talking about the function declaration and the function body as well. So what it allows you to do is the things that inherit from the interface can inherit the same function declarations, the behavior, and they can provide different implementations. The example on the other side here is from a multi-platform desktop and Android application. I needed two things that at a high level needed to behave like a container, navigation pretty much. And so that was why I used that interface there. And this allowed me to interact with these things via the common source set and module. One moment. Excuse me. So if you get into multi-platform development, or if you've even just heard of the expect actual keywords and wonder what they are basically just another way to do interfaces. So what you can do, in this case, we have a module called Compose UI, and it's got three source sets: Android main, common main, desktop main. In the common source set, you define a function or a class, and you give it the expect keyword, and you won't actually write your implementation. So we're defining behavior. And then getting it over, so when we want to actually implement this thing in a source set specific context or whatever, in our platform specific source set is what I'm trying to say. We use the actual keyword. We again have to write the same method declaration, but we can provide whatever implementation we want. So if you've been wondering what expect actual is about, it's basically just the same mechanism using source sets. It's worth discussing that inheritance can actually be used as a weak form of abstraction. Probably all of you knew this. Maybe some of you just didn't think about this. But yeah, for example, we have subclasses of exercise, and we can ferry them around the application by knowing them or referring to them all as their parent class. Obviously, inheritance is also a mechanism for sharing code. Not going to spend a lot of time here. I don't really use abstract classes that much these days. I find their uses are very, very limited. But if you want to know when to use an abstract class, if you want a mechanism with a strong mechanism for sharing code, i.e. implementations, and at the same time you want a mechanism for sharing behavior, abstract classes are pretty much, that's what they're for. So again, caveat. When I first learned about interfaces, I wanted to use them everywhere and anywhere. And some people sort of taught me code to an interface, and on a certain level, that can be value, but we tend to use interfaces way too much when we first learn about them. So Gabor went into this in a lot of detail in his talk about when to use abstractions, I think, interfaces. My general two things to give you here is consider using it when you expect implementations to change. Maybe you have like a very lean testing setup and you want to be able to swap production and test implementations in different source sets or things like that. Or maybe you have an API and you're pretty sure for whatever reason that you might need to swap out to a different one and you don't want those dependencies sort of bleeding out into the rest of the code base. That could be a very useful situation to use an interface. Another smaller known usage is sometimes they're useful if you want to build things in isolation of each other. But at the end of the day, even if you do that, they can end up being an extra pointless layer of code. And if you find yourself having to change the interface all the time, then that can be extra annoying. Apart from that, it's not something I suggest you use everywhere and anywhere, but it is a tool that has its purposes. The third golden principle, which is not so much something that I consider a golden principle for everything, I just find this particularly useful when it comes to at least my experience with multi-platform. Incidentally, where I started to apply this concept of third-party code minimalism is after I did this coding challenge, which required me to, this was back in like 2018, I think. I had to download a file and write a speed test in an Android application without using any third-party libraries. And so I completely epically failed that because I had no idea how to even make a network call using HTTP URL connection or something like that. And while I failed epically there, it sort of spurred this idea in me that I should become a lot more comfortable writing my own solutions to simple problems in particular. So before we get into the benefits of doing that, I just want to spend a moment hopefully clearing up some confusion. And you've got to understand, I'm going to give you some definitions here. They're not going to be agreed upon by every developer. This is just my way of thinking about it. I'm comfortable saying all frameworks are libraries, but not all libraries are frameworks, pretty much. So when I think of a library, I think of some code which was defined in a different project, which I can kind of plug into my project, maybe a different module, depending on how you set things up. When I think of a framework, we have a picture of a steel framework. Based on the name, the only sense I can make out of it is it's something that you build a significant portion of your application architecture around. Some people really like RxJava, for example, and they'll use that as kind of the glue across their application architecture, maybe coroutines or stuff like that. We could also be talking about Compose, which is a UI framework. It's also worth addressing what third party means. Again, my definition. When I think of third party, I think code that has to be either standard library. So here we're talking about Kotlin standard library or Java standard library. Just a quick little note. In Kotlin Multiplatform development, be careful of having your Java standard library in the common main source set because you can run into some issues there. Just a little pro tip. Try to build stuff with a Kotlin standard library. But I'm also thinking of code which is from the Android SDK library. So what does this exclude? It excludes, for example, Jetpack libraries. Even though they are created by the platform, the Android platform people, if it's not part of the SDK library, I don't really consider it to be, I consider it to be third party. So of course, this begs the question, why bother? There's a couple of reasons. One of the main ones I've found is that your code will become more resistant to changes. And the reason why is that standard library code tends to change the slowest over time compared to the other options. Platform code kind of sits in the middle. I'm sure everyone here pretty much is used to dealing with Android SDK changes that totally brick your application. But for the most part, most of the stuff in the platform SDK tends to change slower than the third-party libraries, which tend to change frequently and tend to be less mature code bases. So that's one of the primary reasons why I'm pretty confident that my application that uses HTTP URL connection to make a simple network call is still going to work in probably 5, maybe even 10 years' time. Another reason is that you can write super fast unit tests without worrying about mocking and faking annoying dependencies if you manage to write most of your stuff using the standard library code. You don't even technically need JUnit, but I would still use JUnit. So yeah, that's another useful benefit here, depending on which SDK code you're using, of course. It increases the likelihood that your code can be shared across multiple platforms. And I think I already mentioned this before, but I wrote an application for Android initially. And because I had already taken great pain to sort of isolate that code and use as much standard library as possible, I was able to reuse something like 80% of the code in the desktop port of that application. And then by the end of refactoring things, the Android and desktop applications use something like 95 to 98% same sources for the whole thing. So, yeah. And another sort of less technical thing, which is something that I found, is that there was a time when I was a developer and I really thought being a good developer meant using all the latest and greatest libraries. And I've come to realize that, well, I have to blame the original navigation library for doing this to me, but I came to realize that not every library is worth adopting. And through writing my own solutions, I started to become more familiar with the actual problems behind network communication or navigation and so forth. And that gave me some confidence to actually jump into these libraries and to be able to evaluate whether they were useful for me or not, essentially. So, like everything else I just talked about, there's a point where you can get carried away, and I'm not telling you to never use libraries and to just write everything, just like actually solder your own circuit boards to write your own network connection or network adapter or whatever. What I'm really just saying here is I think it's important for every developer to reach a stage where they're comfortable evaluating other people's code bases, even if it's written by a group or a person who is really respected in the community, because we are all human beings. And there's situations where probably there's situations where your solution might be a lot more efficient. Maybe you don't need to use retrofit and OK HTTP. There's situations where you can take just a part of a library and actually just paste it into your project, assuming it's open source, not telling you to steal code. And then there are certain situations where you really don't want to be writing the code or solving the problem yourself. Like, do I want to be making my own Android UI framework, like alongside Compose? Probably not. Do I want to be making my own image processing library like Glide? Pretty happy to just use Glide. So that's pretty much it. So just a couple of conclusions really quickly, the big takeaways from this talk. Number one, use patterns, principles, and approaches and tools, libraries, only to the extent that they solve more problems than they create. One interesting thing that I've come to see is many teachers will present things like DRY or YAGNI or these sort of abbreviations or principles. And if you spend enough time with them, you will start to see examples where, hold on, I actually did want to do that or actually didn't want to do that. And that's because these are like principles, not always hard, fast rules. With that being said, the unfortunate thing is that very often in order to learn when you're taking something too far, you need to take it too far. Either that or hopefully you just have some senior developers around you who can teach you. So that's really one of the main takeaways here. The second takeaway, just to really emphasize this point, because I know I'm going to get asked about this next weekend in my live stream. What is the best software architecture? Project requirements will dictate the best software architecture. People talk a lot about MVI lately. I'm sure there's certain use cases or situations where it works really well. I'm also sure there's certain situations and edge cases where you're going to have to be fighting against your architectural paradigm in order to solve your problem. My personal approach is I don't actually adhere to any particular architecture these days. So people ask me, do I use MVVM, MVI? I don't use any of them. I really just try to look at the code, separate what makes sense to separate. I try not to fight against the platform like I used to, again, pulling stuff that's tightly coupled to the Android SDK at the far end of 7 layers of abstraction. I try to essentially have my style adapt to the project requirements. And I think that's probably in the long run, hopefully a good approach for you too. So if you would like to communicate with me, I'm generally active on Twitter. So that would be the best place to do that at wiseass301. Do consider checking out my YouTube channel for free Kotlin, Java, Android courses. I have full-length courses on Android, Kotlin, Java, Compose, and I teach this stuff in a lot more detail. I was trying to cover a lot of stuff in a broad way today. My YouTube channel can be found at youtube.com/wiseass. Thank you for listening. Do if you have any questions?
Sweet. We can give everybody a couple minutes to write questions and vote on them. I wrote a question, then went over to the chat area before posting it, and then it deleted it. So now I have to rewrite it.
Thanks, Airmeet.
Yeah, right. Can't you be prepared for all users? You're the streamer. You could just ramble for a little bit while I write too.
Oh, okay, sure. Yeah. Oh, geez. What do I talk about? So just one quick note. I was actually originally hoping to have more of a code emphasized presentation, but unfortunately I was stuck for 3 weeks without a computer and I couldn't finish the iOS port of the multi-platform demo app that I was going to use. So I had to keep it a lot more general. But yeah, I would imagine most people have already gone to bed. So yeah, which is fair enough.
We have 32 people in here right now.
Oh, wow. Oh, yeah, I still see some Europeans. Wow, guys, thank you for sticking it out. I was actually tempted to rename my talk A Beginner's Introduction to Gabor Varadi's talk. I almost did it.
Well, I think maybe you and Gabor need to do a paired session.
Yeah, that could be neat.
We'll host it.
He did basically save one of my live stream specials by jumping on it and talking to me for like 3 hours, which was pretty sweet.
That's Gabor.
Yep.
The man with limitless energy.
The podcast savior.
Yeah. How do you think he has all that energy?
I think it's just genetic because I met some people who can sleep like 5 or 4 to 6 hours a night and not worry about what they eat, and they can function at a high level continuously. And I'm seriously jealous of that because I need at least 8 or 9 hours, and if I eat too many carbs, then my brain shuts down.
I kind of I'm similar on the eating thing with you. Like I need 7 hours, so I'm better than you by an hour. Quantifiably. No. But yeah, man, if I eat sugar, God, Christmas cookies. My wife's German, and she made Christmas cookies. I ate so many cookies. I was on a sugar rush that like it carried me through the whole night, where my brain was just like on rapid fire going insane because I can't function when I'm having sugar. When I was a kid, they thought it was ADHD. Ends up I just needed to change my diet. Still.
Oh yeah, I had a headaches and brain fog for years, and I accidentally found out that all that goes away if I eat a low carb diet. And like everyone's here, we are giving educational talk on diet at Enter Worldwide, but I think diet's an individual thing. But for me, carbs are kryptonite.
Yeah, man. I mean, whatever floats a person's boat to make them feel comfortable, it is what it is. It works if it works. All right. We can kick this off. Tyler's got a question. I'll show it on stage.
So, what is your take on modularizing into smaller Gradle modules in terms of separation of concerns? Is it too much overhead? So, around like 2016 to 2018, I was super into like multi-module Android applications. And I can't remember, I think it was Don Felker just made this tweet like, and the gist of the tweet was like, I don't actually understand why I'm doing this. I'm paraphrasing it. And then I sort of asked myself the question, why am I bothering? And there were some like loose arguments, like maybe it improves compilation time. Um, I don't do multi module for pure Android applications anymore at all. I do think multi module or having multiple Gradle subprojects is very useful in multi platform development. But for Android application, I can only think of a very few situations where that would actually really be useful. So, to answer your question, if you have a good reason to do it, a really good one, I think it's fine. Otherwise, I think it is just pointless overhead and complexity. Oh, have I bumped into any KMM or KMP problems that are yet to be addressed or that have weird workarounds? Quite a few. Um, my sort of biggest, well, maybe I'll get to that in that other question. One weird one was like in the application where I showed some demo code there, I had like a toolbar for the desktop application and for the Android application. And even though the implementation between the Android set and the desktop source set was identical, I still had to put them in separate source sets and have like the whole actual expect and then actual thing. And I guess the reason for that is some dependency under the hood was different for the desktop distribution. So there's a lot of stuff like that. And what I suggest for people is get familiar with the Compose Slack channels in the Kotlin official Slack, because that's pretty much where you'll find all these weird little issues. And generally speaking, you'll find a lot of the workarounds there. But yeah, there's a lot of quirkiness. What are my views about Kotlin Multiplatform? I am really excited about it. I particularly the prospect of writing Compose user interface multi-platform. With that, and one of the main things is I just really like the Kotlin programming language. I really enjoy it. I understand not everyone does. It has some major issues right now. For me, I think the biggest issue in adopting Compose multi-platform is learning how to configure Gradle for it, because it is a nightmare. It's one thing to configure a multi-platform project in Gradle. When you start adding other things like Compose onto that, it sort of just exponentially increases the difficulty. And then you end up, like me, having to spend 30 hours trying to just get Gradle to build, even though you know all the application code should work. So I think they really need to address the. If I was to point to anything that's like the biggest obstacle, it would be learning how to configure Gradle for it, and that is a tricky thing because you're dealing with like, do I have the correct versions of everything, and it's kind of a nightmare right now. So, those are sort of my general views. I'm really excited about it, and I will be doing more live coding once I get the time on multi-platform projects, including iOS, Android, and desktop, and hopefully web as well. All right. Someone named Shalom Halbert asks, what were your favorite resources for learning code architecture? I think if I had to point to one resource, it would probably be Martin Fowler's work. I was for a while really into Robert C. Martin, or Uncle Bob Martin's work. And I did learn a lot of useful stuff from Uncle Bob, and some stuff that still reigns true today. But in terms of just the clarity and precision and just the how it's explained, I really enjoy Martin Fowler's stuff. You can purchase his books. I don't have it with me here, but in my other place, I have Patterns of Enterprise Architecture. You can also just jump on his blog. I don't remember the exact name, but just type in Martin Fowler blog, and you'll jump on there, and you can look up like Martin Fowler on presentation model, also known as model view model architecture. And you'll get information about, for example, model view model architecture that will help you untangle all the mess that MVVM is on Android, for example. So that would be probably my biggest, my favorite resource overall. And then the other thing is, especially these days, I really like to find just good quality open source repositories, code bases that use a particular architecture. And then I'll try and rebuild a simple application. Oftentimes it's just a calculator, for example, a GUI calculator in the new architecture. Because I find separating the problem of solving a complicated problem domain from learning the new architecture, I think those should be kept separate for your learning process. So, yeah. You mentioned doing lots of TDD. How do you go for KMM, especially with the iOS, for mocking what you need to do? Can you point to some resources? It's worth noting, I was hoping to have a lot more experience with iOS on KMM for this talk than I do, but unfortunately I lost, it's a complicated story, but I was without a computer for 3 weeks prior to this talk. So I can't speak to that a lot. I don't actually use mocks. I write my own fakes. So I'm not really sure where to point resources for that. But I'm always going to aggressively use dependency injection. And in critical situations where I know I need like a fake and I know it's actually useful to do that, then I will write a fake and unit test it. For things like databases or that kind of thing, I'm not really going to apply TDD there. I'm going to probably have some integration tests. It's worth spending a moment discussing this. Just as I find there are some architecture zealots, I find there are some TDD zealots that say you have to write every line of code. Sorry, every line of code you write has to be written after failing unit test, and then you want to get 100% code coverage. I don't actually suggest that. There's some parts of your applications you write where you have no excuse to not do that. And then there are parts of your application, like your UI framework code, where I don't actually suggest you go for 100% code coverage. If you can actually pull the presentation logic out into something that is easy to test. And I don't actually suggest you spend like 3 weeks trying to figure out how to write some kind of unit test that's tightly coupled to your user interface or something like that. If you manage to do that and it works for you, great. I personally don't waste time doing that. So this, I'll be repeating a bit of info here, but should we go with multi-module apps? Does it help with Gradle speed? I mean, separate project for each layer. Like I said before, don't do multi-module unless you have a reason to do multi-module. When I did it originally, it was just because I saw some senior developer do it and I wanted to be cool. And that's a terrible reason to do something. If you don't have a reason, don't do it. I found, generally speaking, so I would hear this now and again that multi-module could speed up your Gradle builds using, I think, incremental builds or something like that. So I think the idea is that you don't recompile every module, just the one that you want to recompile. In practice, I found the overhead of dealing with the dependencies between these different modules and all this configuration never actually paid off in terms of faster Gradle builds. Do I have the numbers for benchmarks in front of me? No, that is something you could check on that. I just, so separate project for each layer. That in particular, I don't suggest. Like I say, if you're doing multi-platform, yes, that's a great time to use multi-module. If you're just writing a native Android app, really question what you're doing.
Sorry, I marked one question as answered that wasn't answered yet.
It's all good.
And it wasn't an important one in the end, but I'll show it anyways because Todd clearly wants it.
Vim. Yeah. So the question is Vim, or I think Vim, unless VI is something else. So Vim or Emacs. So these are different IDEs, for lack of a better term, in Linux. I'm kind of one of those people that I don't like to spend a lot of time screwing around with my IDE, where some people really like to make it their own and that kind of thing. Emacs was just way too much complexity for me, and after a while I could use Vim fairly reasonably, but yeah, that's pretty much all I have to say there.
Okay, any comments that would into the chat area? Oh, looks everything's fine. All right, cool. Then this was fun. Brian, thank you very much.
Thank you, Shalom. It's been a pleasure.
Oh, the pleasure is all ours. And if anybody is unaware, Ryan does have his own YouTube channel where you might find a lot of entertainment. So I highly recommend going over there, like checking out Ryan's YouTube channel. Yeah, I mean, just check out a live stream. It's a fun time. Worst case scenario, Gabor will show up and just tear it to shreds. Best case scenario, Gabor doesn't show up. No.
It's a mixed bag when he shows up. I'll give an answer in it. That actually, it's like, oh damn it. I always appreciate when Gabor shows up. Florian from Coding and Flow had this tweet, what it's like when Gabor shows up to your coding live stream. And it's like this guy teaching a lady to golf by like wrapping her hands around it. Easier to describe with the actual picture, but that's what it feels like when Gabor shows up. You feel like you're taken care of.
He's a sweetheart. All right. I guess those are the last words.
Yeah. Thank you so much, Shalom, and everyone at Andrew Worldwide. It's been a pleasure.
Oh, no, pleasure is ours. You are fantastic. Your energy is remarkable. Thank you. All righty, folks. Ciao, ciao. Or see you in 5.
Auf Wiedersehen.